Hey guys, I'm Volen and welcome to day 14 of Advent of Code. So let's go over the story. Restroom readout? One of the historians needs to use the bathroom. Fortunately, you know there's a bathroom near an unvisited location on the list, and so you're all quickly teleported directly to the lobby of Easter Bunny headquarters. Unfortunately, EBHQ, Easter Bunny headquarters, seems to have improved bathroom security again after your last visit. The area outside the bathroom is swarming with robots. To get the historian safely to the bathroom, you'll need to find a way to predict where the robots will be in the future. Fortunately, they all seem to be moving on the tile floor in predictable straight lines. You make a list, your puzzle input, of all of the robots' current positions, P, and velocities, V. One robot per line, for example, each robot's position is given as P is X, Y, where X represents the number of tiles the robot is from the left wall and Y represents the number of tiles from the top wall, when viewed from above. So a position of P00 means the robot is all the way in the top left corner. Each robot's velocity is given as Vxy, where X and Y are given in the tiles per second. Positive X means the robot is moving to the right and positive Y means the robot is moving down. So a velocity of 1, -2 means that each second the robot moves 1 tile to the right and 2 tiles up. The robots outside the actual bathroom are in a space which is 101 tiles wide and 103 tiles tall when viewed from above. However, in this example the robots are in a space which is only 11 tiles wide and 7 tiles tall. The robots are good at navigating over under each other due to a combination of springs, extendable legs and quadcopters. So they can share the same tile and don't interact with each other. Visually, the number of robots on each tile in this example looks like this. Okay, so I guess I need to make some kind of visual example again to make certain that nothing goes wrong with my code. These robots have a unique feature for maximum bathroom security. They can teleport. When a robot would run into an edge of the space they're in, they instead teleport to the other side, effectively wrapping around the edges. Here is what robot P2, 4, 2, -3 does for the first few seconds. Initial state, so it moves up, it moves right by 2, right by 2, 3 times up. And the historians can't wait much longer, so you don't have to simulate the robots for very long. Where will the robots be after 100 seconds? In the above example, the number of robots on each tile after 100 seconds has elapsed looks like this. To determine the safest area, count the number of robots in each quadrant. After 100 seconds, robots that are exactly in the middle, horizontally or vertically, don't count as being in any quadrant, so the only relevant robots are... Okay. In this example, the quadrants contain 1, 3, 4 and 1 robot. Multiplying these together gives a total safety factor of 12. Predict the motion of the robots in your list within a space which is 101 tiles wide and 103 tiles tall. What will the safety factor be after exactly 100 seconds have elapsed? Okay, what will be my plan of action? I think I should create some kind of like map checking. So I need a function to like print a map just in case. So func print map, and this will need to print out a map with the data. Okay, so I think I should probably create a class for the robots within 100 seconds. I feel like... And count the number of robots in each quadrant after 100 seconds. This is actually a very easy thing to do. Yeah, this is actually... I don't even think I would need to print the map, to be honest. Like, I just take the steps that they do, like so from the data, from test data, so we have this. We just take the vectors and do that times 100. And then just calculate where the position will be in a certain amount of times. This is easy. Or I'm missing something, but for me, this is starting to sound quite easy. Oh well, let's see how easy it is. So, I'll quickly make a plan. Okay, so first plan is actually not too difficult. So first off, we get all the lines from the text file and we send each line to calculate positions and save data to a well, saved to a data variable, like to an array. And then we just send that array from all the positions that we've gotten to calculate quadrants. We only need to do times 100, so this does not feel like it will cause any issues. I think this is basically all we need to do. So we calculate the positions, and that's just, we do times 100, and then we just do percentage, like the percentage map size, and then we get the remainder from that. So this should normally work without issues. And then for calculate quadrants, we basically divide in 4 groups. 4 groups according to x and y, and then just multiply, like add those numbers. I thought this will be more challenging, but it's probably going to be an optimization thing again, and then in part 2. Oh well, let's see. I'll get to coding. Okay, and this is the code that I have so far. So we create a variable with positions, we go over every line and we calculate the position of it. We basically handle the string inside of this function as well to get the coordinates and the velocity. And the velocity we directly do times 100. Then for the position, we do the percentage sign map size.x and map size.y. But just to make certain that the negative values don't stay negative, we do this. Basically, we add the position if it's under 0. And then we return the position. And then for, calculating the quadrants, I have not done this yet. I just created a small function to print out the map. So I'll func print map. I wanted to do this because I felt like if I don't do this, I will possibly regret it later on. So, but yeah, this kind of works. Well, I should probably finish the function that I'm writing on. Factor to I, and then here I should probably do this. Let's delete this. And if you run this, we have our if we print this, we have our map, which is equal to this one. So it's an exact copy. Now we need to divide the thing in 2. And I think floor that level. So yeah. But basically remove the lines from the middle. That's by using floor function map size divided by 2. So it's not going to be too difficult. So I don't know what part 2 will be, but I hope it will not require me to redo this entire code thing. So yeah, let's see. Let's see how this goes. I think optimization will be needed again, and it will be math related again. Okay, and a little while later I have this function, the calculate quadrants function. So first off, we calculate where are the different sides, like what is like the minimum square size of each quadrant. So then we basically check the left half, top, bottom, right half, bottom, and we add them to each individual number. So this should be the left top, left bottom, right top, right bottom. And then we make certain that there are no zeros, because if there will be a 0, that will be an issue. Doing times 0 results in 0 either way. So just as like a very edge case, if that were to ever happen. And these integer divisions, I don't like them. Okay, and this should work. So 12. Okay, and let's take our normal data. I am not looking forward for part 2. I have no idea what part 2 will be, but it will probably be some kind of like optimization. Okay, so we are printing the map as well still, so maybe I should like print the map whilst like not having the line of the quadrants. Will maybe be kind of nice. Or use print rich and have the middle line in red or something. But I should not spend too much time in like making this look clean. I cannot grab this thing. Okay, finally. Okay, so let's see if I got the correct answer. Let's hope. Yes, that's the right answer. You are 1 gold star close to finding a chief historian. And I did that in around 40 minutes. Okay, so part 2. During the bathroom break, someone notices that these robots seem awfully similar to ones built and used at the North Pole. If they're the same type of robots, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that must elapse for the robots to display an Easter egg? I don't even know how this Easter egg is supposed to look like. Okay, so this is basically not going to be possible then. Yeah, I will need to go over them one by one. But I don't know how it can display a Christmas tree. Does the test result also display a Christmas tree? Can you make a Christmas tree with 12 characters? Okay, so apparently that does happen, that they form a Christmas tree. 12 is possible. The only thing is we don't know in which location they will make that Christmas tree, which makes it kind of annoying. I'd like to think that they will make it in the middle, but what I will do is adjust my codes to create the whole, to actually do it by seconds. And then I will just have an extra line of code that will check if a lot of them are in a line. So we'll basically go over all the lines on the map and see if the values line up. Oh well, let's get to coding. I think I can do this. This does not sound too difficult. We just need to make certain that we have the bottom line correctly. And if that gives false alarms, then maybe I should also check just for the complete top, if that is also present. Let's see. Okay, and a couple things have changed. So I'm counting the robots, and I made a robot class. So if you go to the bottom of this script, we save the position and the velocity, and we just extracted the part of the calculate position script. After that, we first create all the robots to fill in all the robot slots in the array, and then we go into a while loop, and we do that until we find a Christmas? Until we find a Christmas tree. I first want to do a check. If you do 100 steps, do we get the same result? So, okay, we do. And now it's basically kind of brute forcing. And the way that I'm trying to find if there's a Christmas tree is by going over the entire line and counting the amounts of hashtags in the map. If that is bigger than the L robot size divided by 2, then we normally have a Christmas tree. So this will take some time. I know there's probably some kind of mathematical thing that I can use to calculate how many steps are needed for them all to be in a specific line. I cannot be bothered, so I'm kind of brute forcing. This takes a little bit too long. Okay, so at some point I should form a Christmas tree, but I see some kind of pattern happening in the numbers itself, so I don't see anything that looks like a Christmas tree. So we need a lot more. Let's try 200. Oh, there's some lines here. I still don't see a Christmas tree. Oh, is it a Christmas tree? I don't know what the pattern is of the Christmas tree. Is it oh, whoops. Is it just a triangle, but with the numbers all in between? What is the pattern of the Christmas tree? How does the Christmas tree look? And is there a pattern that is exactly the same? Are we going over the exact same patterns the entire time? I can see something forming every now and then. I don't know how the Christmas tree looks, and the example also does not show how it looks. So if they're the same type of robots, they should have a hard-coded Easter egg. Very rarely, yeah, apparently very rarely. Most of the robots should arrange themselves into a picture of most of the robots, so not all of them. So wait, how big are we talking then if we talk about most. Like this? This is supposed to be a Christmas tree? Like what counts as a Christmas tree? I really thought I had it. Like this is a Christmas tree for me. So for me, it should be in this kind of position. So why is it not? Do I just let my code run for like a good 5 minutes to like see if something changes? Like I do see this entire pattern the whole time. Wait. I saw another pattern like that with like 3. Wait, I think we're getting the same patterns. There should be a Christmas tree instead of here. What counts as a Christmas tree? I don't see a Christmas tree in this, and this either, and this also not. In this, nope, nope. What counts as a Christmas tree? What is a Christmas tree? Whilst going over this code, like the thing here, Easter egg, I hovered over this and I saw something pop up. This puzzle was originally going to be about the motion of space rocks in fictionist arcade games called Meteoroids, but you just had an arcade puzzle. So does that have anything to do with this question of how the like Christmas tree should look like? I don't know how I can calculate this. How I can like find a Christmas tree. I don't know the shape of the Christmas tree. Okay, so I've basically tried a little bit and I cannot find any Christmas tree in the test example and test data, so I think there's just no Christmas tree at all. They do say in here that it's a picture of a Christmas tree, so there should be a frame. So my method of like trying to count the amount of, well, hashtags still exists. So I just need to try and find the hashtag thing. If I can find the hashtag thing, then I got my picture. And yeah, I don't know. Like I will just let this code run, and normally it will stop if it finds if line count. Yeah, we continue, and we split on the dot. That will be kind of processor intensive. But at this moment, I don't know what else to do anymore. We're already skipping most of the things if there are no 20 robots in one line. And if you find a line that has over 18, then like 18 in a row, that we print. So I don't think it will happen that often that there are 18 in a row. I do 20 and 18 because this is over the entire line. So yeah, let's see. I will let this run and I'll hope for good luck. In the meantime, I will have snack time. Okay, so part 1, that went. Part 2, let's see what happens. Right now it's 3:38. So yeah. Okay, so this actually took a lot less time than I thought it would, and it's almost exactly in the middle of the I think it's exactly in the middle of the picture. Yeah, this is a Christmas tree, so this should work. Let's see. That's the right answer. You're 1 gold star close to finding Chief Historian. I found this a much nicer part 2 than yesterday. Oh well, I finished. I still have not done day 13. Like part 2 of day 13. I don't think I will do it, so I'll probably have 1 star lacking at all times. But yeah. Anyways, thanks to my coffee supporters for supporting me, and I'll see you all tomorrow in the next one. Bye bye.